And we're live. Hello, and welcome to the Virtual Eclipse Community Meetup. I'm your host, Stephanie Swart, and I'm joined by my colleague, Roxanne, and our guest host, Jonas Helming from Eclipse Source. This is our first Eclipse Community Meetup after a bit of a hiatus, but now we're back, and we'll be hosting Virtual Eclipse Community Meetups twice a month. So today's meetup, as previously stated, will be run by Jonas, who will be presenting on EMF Forms. So without further ado, take it away, Jonas.
Hello, thank you, Stephanie, for the introduction, and hello, everyone who joins the meetup. Thank you for joining, and yeah, I'm having the honor to give a talk today about EMF Forms. So let me switch to my slides, and let me share my screen first. Here we go, and those are the slides. Okay, what I would like to do today is talk about a framework, one Eclipse framework called EMF Forms, which is targeted at building form-based UIs. The talk is targeted at people who do not know the framework yet or are just getting started with it, so it's an introduction talk. I will quickly explain the motivation behind the framework and how it basically works, and then I will directly dive into a demonstration and show you the most important steps to get started with the framework. Those steps are actually derived from our experience in answering newsgroup questions. So we basically derived like the 6 or 7 most frequently asked questions for beginners, and I will try to answer those in the session today. So hopefully after the talk you should be able to get started with the framework more easily, or alternatively you should have a better decision ground on whether this framework is interesting for you or not. Okay, so what is EMF Forms, or more precisely, what's the motivation behind that? Before we talk about the motivation, let's quickly define the area we're in. So we're talking about form-based UIs, and by form-based UI, we mean those typical UIs you have in almost every application where you show some data in input fields, typically with a label, could be a text field, a number field, a date field, depending on the data type. So you show the data, the user can modify it, the user can enter new data, and you need some kind of layout facility. And it doesn't really matter, so conceptually it doesn't really matter whether we are on the desktop as seen here, or in a web application, or even on a mobile device. So the approach that I will demonstrate basically works on all different platforms. I will focus on SWT and desktop versions today. However, at the end, I will give a small outlook on other platforms where you can use the same technology. Okay, so what's wrong with the current way of developing forms? Because the most obvious way would just be to manually do that, for example, in SWT. So typically you have a data entity that you somehow want to visualize in the form-based UI, and you would instantiate labels, text fields, use data binding and all this stuff. So what's wrong with that? The biggest problem is actually the effort. If we take the most simple example of a form that we can come up with, and that's just one text field showing one attribute, in this example, first name. Now, if you implement that, you instantiate a label, a text field, a layout for those two elements. You need to bind the data, and if it's a real form, you should add some validation of the input. Now, if we do that in SWT, the code looks pretty much like this. So it's very surprising how much code there actually is required for such a simple feature, because it looks very simple, but again, you have to create at least the 2 elements, a small layout, you have to instantiate data binding. If you don't do that, you have to deal with listeners, and in a real application, you would need some kind of validation. Now, problem becomes even worse if you have a more complex form. So it's still not complex, but it contains only 4 elements. So let's assume you can just reuse the first code that you've written, because for the next text field you use the same code, but you just bind to a different attribute. Of course, we would have to repeat the code for other types then, at least partially. But the other thing that comes in if you have several controls in a form is the layout. And the layout that we see on the left side is pretty much this code now on the right side. So we have even more code, but still the feature is very simple on the left side. Now, it's actually interesting to observe that, first of all, the effort of writing forms manually is often underestimated. We believe that the reason for that is because it sounds so simple. And second, statistics show that in business projects, in average, 40% of the development time are spent on the UI, which is also a surprisingly high number because you would expect, okay, things like persistence or business logic take a lot of effort, but not 40% for the UI. Long story short, EMF Forms tries to solve that problem, and that's basically done by describing forms more efficiently. If we look at this simple example again, now a form with only one attribute. The most important information that we need to specify for this form is actually which attribute we show here. From this information, we could actually look at the data entity. We could derive the attribute type, in this case a string, and then there could be a framework which just creates this field for us because all the other stuff is typically pretty much the same. Now, EMF Forms does exactly that. So instead of writing all the code that I had on my previous slide, in EMF Forms, you just need to specify which attribute to show. On the right side, we see now what we call a view model. That's a very simple modeling language introduced by EMF Forms. So it's a declarative language. And the current instance just has two nodes. The top one is just a container, so that's not so important. The leaf node, the control, actually specifies that we want to show a control here, and that this control shows the attribute first name from the data model. And that's actually already enough for EMF Forms to render a control that is shown on the right, on the left side. Now, let's take this example further to the more complex form with only with 4 attributes. Now, that's pretty straightforward. In this case, we would just need to add 3 more controls for the other attributes. Now, the layout that's actually implicitly shown on the left side would be automatically derived from the fact that those controls are placed just in a row. Of course, you typically want to have more complex layouts, and I will show in the demonstration how to model that then. But the simple form on the left side could literally just be described by the artifact on the right side. So we see in comparison to write the code on the previous slide, we save a lot of specification effort and thereby a lot of development effort. Features like validation and the labels and, for example, mandatory marking that we see for last name would be ideally automatically derived from the data model then, and I will also demonstrate that. Now, now that we have introduced this new way of describing forms, there's obviously something missing because if we just have this declarative way of describing forms, we have a nice way of describing it, but we don't have a form. So there is obviously a component missing. So here we see the whole picture. Now, when working with EMF Forms, there are 2 artifacts used as an input. The first one is the data model, or the data entities, basically. Those are basically the Java classes from which you want to show and modify data in your form. We need some description for that. That by default, that's done in eCore. That's the modeling language of the Eclipse modeling framework. But you could also use XSD or UML or any standardized way of describing those entities. I'm saying you can use any of those because they are pretty much or very easy to transform to each other. So if you have an XSD, you can generate an eCore from that, and the same is true for UML. So any formal data description would do on this side. And ideally, you already have this in your project. If not, you can, for example, derive that from a database, or if you just have Java beans, you can also derive that from the Java interface. Now, the second artifact, which is added by EMF Forms, and that's the only artifact which is really specific to EMF Forms, is the view model that I've just talked about. So this is a description of the UI only. So it will not repeat the definition of your data done in the data model, but it will only reference that. So the only information stored here is which attributes are shown in the UI and how they are layouted, plus a couple of constraints I will demonstrate later. So those are the two artifacts that you need. And now from those two artifacts, there's no code generated or anything, but actually they are interpreted by a rendering component during runtime, so that we see this component we see here above the equal sign. And this rendering component processes exactly those two parameters or those two artifacts as a parameter. And based on this information, it will actually create a user interface then. As you can already see on the right side, there could be different user interfaces for the same definition. So standard would be in SWT, but you could show the same UI then using another renderer in the web or on a mobile device and so on. And I will talk about this at the end of my talk again. But let's just assume there is some SWT code which interprets the data model and the view model and thereby produces an SWT UI. Okay, so long story short, that is the concept behind EMF Forms. So let's dive into the demonstration. And for that, or in the demonstration, I will try to answer the most frequent question that we get. The first obvious question is how to get started. So what are the first steps if I want to try out the framework or if I want to use it in my project? So let's switch to my IDE. What I have here is a standard Oxygen 1 Eclipse, and I use the modeling tools. That's a standard package that you can install or download that has the advantage that EMF Forms is already installed in that, so you don't have to download or install anything in addition. The other thing, or actually the only thing that I prepared besides the IDE itself, is that I already created an example model in my IDE. This is a data model, so that has nothing to do with EMF Forms yet. And I would just use this data model and create a form-based UI for this specific data model. In case you want to try that out yourself, you can instantiate this data model also in every Eclipse modeling tools edition by clicking on New Example, and then in the category EMF Forms, you select Example Model, and then you would have exactly the same state. So let's have a quick look at the example model. If you know EMF, there is, for EMF data models, there's always a formal description in a file called eCore. So this file actually describes how the data entities of my application look like. In this example model, we have 3 example entities: task, user, and user group. Now let's focus on user only, and let's open this. And here we see all the attributes that are defined for user. And as you can see, there are attributes like first name, a string, last name, a string, gender, which is in enumeration, active, which is a Boolean, and so on and so forth. If you are from plain Java, you can just assume, okay, you would just write a Java bean with all those attributes. Now, in the EMF case, you can generate the Java code based on the model. And let's have a quick look at that. So we open the user interface, and let's look at the outline of that. And here you can see, so there's a getter and a setter for first name and the same for all other attributes. So if you're unfamiliar with EMF, you can assume we are working with Java Beans here. The EMF entities have some additional features, but that doesn't really play a role at the moment. Okay, so now let's assume we would like to create a UI which allows to modify and enter the attributes of a user. Now, EMF Forms provides a wizard to automatically derive a first version of the view model from the data model. That has the advantage that we don't have to create all those controls that we need later manually, but they are actually already pre-filled. If you want to use that, you can right-click on an echo file, and there is an entry EMF Forms, and this allows to create a view model project. This will actually create a separate bundle containing the view model then, and it's actually good practice to separate the description of the UI from the data model for separation of concerns. Now I will just accept the default name, and now you can see that EMF Forms already processes the data model, so it has detected that there are 3 entities in. In my example, I would like to create a form for the user. Down here, I can select whether I want the view model to be filled with the default layout. This would just create one control for every attribute, and it would just place them in a flat vertical layout, like line by line. Okay, so let's finish that. Now we can see down here, the new bundle has been created, and it currently just contains the view model. In the middle, we can see the editor, which is also delivered with EMF Forms, allowing me to look at this declarative model. So it's more comfortable than modifying the underlying file. And what I can see is that the wizard created one entry for every attribute in the data model. So those are exactly the attributes that a user defines. Now, I could now start to work with that. Obviously, this is now a pretty abstract view on your UI. If you get familiar with that, it's pretty much fine, but somehow you want to see, okay, how would this reflect now in a rendered UI? Now, for that purpose, the tooling also provides a preview, which I will open now. So now down here, we see how this form, which is modeled here, would be rendered using the default rendering set. And what we can see down here is this is already a fully working form. So I can enter values here. We see there is already validation in place. So the last name field is specified as mandatory. That's why we also have this asterisk here. And there's currently a validation error because I didn't enter anything, and only if I enter something here, the validation error is gone. What we can also observe is that EMF Forms provides default controls for every data type. So for example, for the nationality, which is an enum, I see a drop-down list of all the possible values. For date of birth, which is a date, I can choose my birthday. Active is a Boolean, and so on and so forth. So what you get out of this with actually pretty much 3 clicks is already a working form, which already binds to the underlying data, that you can see that the validation actually already works. Okay, now if you change something over here, that's directly reflected. So if I, for example, delete the first attribute and I refresh this down here, that's gone. And the opposite direction, I can also just re-add that. For that, there is a wizard to generate those controls again. Again, I select the entity I'm working with. And now I see all the attributes derived from the entity. So I could select first name. One pretty neat feature is that you can show only the attributes which are currently not yet in the form. That's the first name because I deleted that. And then I have this back again. Okay, so that should be it for so let's continue with the next frequently asked question. So that's obviously, what about layouts? The current form is really very simple. It's just a flat list of attributes, and in any real application, may it be a tool or a business application, that's not what you want at the end. You need some layouting capabilities. Now, EMF Forms has support for that. So let me demonstrate that. Currently, we have only one type in our view model, and that's a control. A control is actually a reference to the data model and is indicating that there should be an input field in your form. There is a second type of view model element, which we call a container. A container allows to group controls in a hierarchy and thereby express a layout. The layout is actually then produced finally by the rendering component. So you can. So this is pretty much parallel to HTML, where you would structure your content, for example, in paragraphs, and then the browser actually translates this information to a visible UI at the end. So let's do an example for that. So currently we have a flat list, and now let me remove this one because this is a little bit big. Now I start to create layouts. As you can see, the list of available elements is not too big. That's mainly due to the higher level of abstraction that we are in. However, this list has been developed over 6 years now, and there's barely any layout that we cannot produce with those elements. Now, what I do is I create a horizontal layout as a first element. That's a very simple one. It would just display its children horizontally aligned. And in this horizontal layout, I create 2 groups. One I would call left, and the other one I would call right. Like this. And now what I can do, and that's pretty good compared to code, I can just drag things around. So for example, I could place those controls in the first group and those controls in the second group. Oh, that was not correct. Down here. And then I just refresh the form. And now you see that we already have a better layout, so things are actually grouped together. Probably I want to change the order over here, that this looks a bit better, but this is then fine-tuning. Now, I will not show more layouts for today. There are quite a few more layouts. One of particular interest is a control grid. If you have layouts where, for example, in the first line you have 2 controls, in the second and 3, and then only 1, and you want things to align well, there is an element making that happen. In general, all layouts are still on a much higher level than if you deal with SWT, for example, so you never have to define single spans or something like that. Reason why this is possible is that EMF Forms is actually explicitly focused on forms. So the framework actually understands that you create a form and not a general purpose UI, so it can make some good assumptions about the layout that you want to have, especially also about the alignment. One thing that I would like to show here is that what we try to do in the framework, and that's pretty consistent, is that the layouts are as abstract as possible. What does that mean? A group, for example, just indicates that you want to group the things which are contained in the group. The standard renderer would just draw a border around them and add a title, but you could imagine different visualizations of those groups. So you can actually influence that yourself. I will show that in a minute. But also the framework already provides different ways of rendering a group. For example, I can switch this group to collapsible, and then I just refresh that down here. And now the right group can actually be collapsed. So it's a different SWT element now, but still the same view model, kind of. And this allows a lot of flexibility, even at a later point in the project, to tweak your UI exactly the way you want it. Okay, so let's head over to the next question. And that's how to embed those forms. Now, we have a working form and we have some basic layout, and hopefully you believe that you can also create complex layouts with the framework. However, it's still in your IDE, but at the end of the day, you want to have that in your running application. So how to do that? To demonstrate that, I will instantiate another example plugin, so I don't have to create an application from scratch. This is again part of your Eclipse modeling IDE, and I will choose the sample E4 application example. Just click on Finish. And now I have a new bundle in my workspace, which is a very simple Eclipse application. It just contains one part, which we will have a look at. This part basically does two things. In the first method, getDummyObject, it creates a user. That's the data entity. So this doesn't yet have anything to do with EMF Forms, but we need this data entity to actually fill the UI. Now, if you embed EMF Forms in your own application, you would typically retrieve this data entity from another source, like from a file, from a database, from a service, wherever you get your data from. And now the interesting part is the second method. The first 4 lines basically configure the composite of the one and only view in our application. So what we do there is we set a white background and we configure some margins so that the form doesn't completely go to the borders of the view. And then the only call related to EMF Forms is this one. So we call the renderer, the central rendering component. And as a parameter, we need the parent composite. So that's an SWT composite plus the input object. You might wonder why we don't pass the view model, which we specified. View models are automatically registered as at a central registry. And if you don't have several view models for the same entity, it will automatically pick up the right one. However, I can also, as an optional parameter, pass in the view model if I would like to. So let's start this application. And hopefully it comes, oh yeah, it's on the same screen. So now we see exactly the same form that we had in the IDE on my in my running application. And we can see the margins and everything is exactly the same. And still the data is bound. So I have exactly what I had in my preview. Now, because EMF Forms just requires a parent composite, you can embed EMF Forms at literally any place in your application. So that could be a dialog, a window, a preference dialog, a details pane, wherever you want to use EMF Forms. Okay, let's switch to the next question. That's a very common one once you have had a quick look at the framework. It looks very nice for prototyping, but what happens if you are unhappy with the way that EMF Forms renders a specific element? So for example, you're unhappy with the layout that is provided, or you're unhappy with a specific control. The good news is actually that you can customize literally everything in the UI which is produced by EMF Forms. And the reason for that, so let me bring up the preview again, that there is not only one big rendering component which creates the whole UI with a lot of code. In fact, there's at least one renderer per element in this UI, so it's very modular. So for example, there is one renderer creating this group here around. There's one renderer creating the text field, the enum field, the Boolean field, and so on. And for some for some elements, the framework even provides several renderers already. So for example, for the group, I've shown before that I can switch them to collapsible. So this is actually already a second renderer in the framework. And now, because all renderers are separated, EMF Forms also provides a way for you to register your own renderer and thereby completely replace the current way that the framework renders certain elements. So let me show you an example for that. What I would like to do is replace the way that EMF Forms renders the standard group again. We have seen the framework already delivers a second one. but I would like to implement a third one and render the group not with SWT standard anymore, but with a Nebula P group. That's just another container element. So to demonstrate that, I will instantiate another example. So you can also try that yourself, again, in the Oxygen Modeling Edition. And this is called Custom Group Render. So let's instantiate that. And now before we start that, let's have a quick look at the code. Every renderer consists of two components. The first component is called a renderer service. This component will instantiate the renderer, but even more important, it will decide when a certain renderer is applied. And for this, you need to implement one method called isApplicable. This gets in some information, for example, the view model element which is currently rendered, for example, whether that's a group, and the context where you can access all relevant information. So for example, you could access, in case of a control renderer, which attribute is currently rendered, or you could access the information, what's the first letter of the attribute name or whatever. Now, by implementing this method, you can literally integrate any criteria you want when your specific renderer should be picked. So for example, for all string attributes, for all enums with more than 3 literals, or whatever criteria you want, down to that you can only register render for one specific attribute. In our case, this renderer will check whether the view model element to be rendered is a group, and if not, it will not be picked, and if yes, it will return a priority which is higher than the default renderer. So this renderer will be picked up for all groups subsequently. And now let's look at the interesting part, which is the group renderer itself. As you can see, it only consists of 130 lines of code, and actually the only important part is in here. The rest is basically wiring some services. So this actually creates now the UI. What it does is it creates a P group. That's done here. That's the Nebula element, so an alternative for the SWT group. It sets the label of this group to the element that is specified in the view model. That's done in this line. And what's happening down here is it registers a listener to the expand listener to the P group, because a P group can be collapsed and expanded. And if this happens, the parent layout has to refresh, because there could be more space or less space. For those things, in many cases, there is an existing EMF Forms service which will automatically do that for you. So you just need to call the layout service, and this will actually find out which of the parent elements need a relayout. And that's actually already it. So let's integrate this new renderer into my run configuration so that we can see the result. Just add this renderer and then restart the application. And then the group should look differently. So now you can see a completely different design, and the groups are actually collapsible because I replaced the renderer. And exactly the same way you can replace any element which is placed in this UI that includes the controls themselves. So if you don't want to display a text field, or you need auto-completion on the text fields and so on, you can actually write your own controls. The good thing about that is writing your own controls is actually not more effort than manually writing them as you would do if you manually code that. The advantage is that this is already embedded in a working container. So you can only implement the stuff that you want or that you want to customize, and you can do that step by step, but you still have a overall working form. The other good news is that a lot of standard functionalities, for example, propagating those validation messages, is already done by the framework. So you don't have to do that again, but you can just consume them in, as services. Okay. Another feature that is frequently requested is visibility or enablement rules. So let me quickly demonstrate that. Background for this is that in a lot of forms, you have some conditions under which you want to show certain fields or enable them. If you manually do that, that's actually typically pretty ugly to implement, because some UI components are kind of depending on the state of others. In EMF Forms, you can express those conditions in the view model directly, and the forms would automatically behave according to that. So let's assume, I just make up an arbitrary example. Let's assume we don't want to ask German people for their first name. So if you pick nationality German, then we don't want to show the first name field. Important, this doesn't make any sense. So I'm not implying any any data security stuff here. So what I do is in the view model, I add a so-called show rule to the element, and I set this to hide. That means this rule will hide the first name element. And now I add a condition to that. I can have compound condition, but in my case, it's a simple one. So it's just a leave condition. And now this leave condition can point to arbitrary values. In my case, it will point to another attribute. And that's, in my case, the nationality, because this rule depends on the nationality. And now in the condition, I specify when this is true. So in my case, I want this to be true if German is actually selected, like this. Now, if this condition is true, then the show rule will kick in and it will hide the parent element. So let's try this. If I now set this to German, then the field is gone down there. So as you can see, pretty simple specification. And if you have implemented that yourself, you know that this can be pretty ugly. This does not only work for controls, it also works for container elements. So for example, if I move this condition up here, then, and I refresh this, then this group is gone, and it comes back when I select another language again, or nationality. Okay, the final feature that I would like to demonstrate is tables. I've shown a lot about forms, but EMF Forms also supports tables well, which are pretty much in parallel to forms, also a lot of effort to implement manually. So for tables, I need one more data entity. I could show users in a table, but as an input object, I need a container for users instead. And luckily, my data model already has such a container, and that's a user group. So if we look at a user group, this contains a list of users. So what I do is I choose user group as an input object and then show a table which shows a list of users, basically. So to do that, I would just create a second view model now for this second entity. In this case, I will select user group. I will not fill it with a default layout because I don't want to show the other parameters, only the users. And I will place it in the same directory. Now I have an empty view model. And now in this empty view model, I will create a table control. In this table control, I have now, as a first thing, I have to specify where the data is actually coming from. And this data is coming from the referenced users. So that's the list of users. So let me specify that. And now, so the table knows now that it shows users. It doesn't define any columns yet. But because I know the underlying data model, I can now just generate those columns. And now we see there's a list of all the available attributes. So I could remove some now, but let's just leave it as it is. And now let's have a look at the form. Now you can see it creates a fully working table for you, which shows users. You can also see that the validation automatically works based on the same concept, and we have cell renderers for all basic types again. As for the forms, you can adapt all this. So if you want to have different cell renderers, you can just plug them in. And the last thing that I would like to demo, tables are another good example where this abstract definition of the UI pays off. Because again, a table control doesn't necessarily mean that you render this with an SWT table. And if you know SWT table, it's not really powerful. Now let's assume you start with SWT table, but then you experience that you want to switch to another table implementation. In the case of EMF Forms, the specification stays the same. So I will just switch to another table implementation, which is delivered by default, and that's with grid table, for example. Now, as you can see down here, the table looks completely different, and technically it's really a different element, but the feature is exactly the same. Even the input has remained the same. The nice thing about this Nebula grid table is that it supports single cell selection, so you can do things like this, can copy paste and so on. Yeah, that would be it about the tables. Good. So let me come to an end. After those initial questions that I've tried to answer today, there are obviously much more questions, especially about, does EMF support a certain feature? Now, we're very actively developing the framework since 6 years, and there are a lot of big projects using the framework. So the probability that your specific feature, if it's not too custom, is already supported by the framework is pretty high. So it's worth asking for that and browsing the documentation. The good news is, even if EMF Forms doesn't support a specific feature, as I've partly shown today, it's very extensible. Plus, we provide sponsored development for if you're missing a certain feature. And as it is a Eclipse project, you can also contribute missing features yourself, obviously. Final word about UI technologies. So today we have, I've shown SWT mainly. However, you can also render this differently, just by replacing the render again. So what we see here is the same thing in wrap. That's obviously also against the SWT API with some minor adaptations. So those are the two reference renderers, SWT and wrap. We have a proof of concept for JavaFX as well. Plus, there is a completely independent renderer of that called JSON Forms, which renders the view model artifacts plus a data definition based on pure web technology in JavaScript, so on Angular or React. This has a different name because it's not based on EMF as a data model, but on JSON schema and JSON as a data input object. So if you're interested in the web version of this, then Google for JSON Forms or go to jasonforms.io. Okay, that would be it. I hope I could answer some of your questions, and I hope you got an impression of the framework. If so, I will take questions now. If there are any questions left, I'm also happy to answer them via email. Okay, are there any questions? Are you still there?
Thanks, Jonas. So right now we're waiting for everyone to ask questions. So either in the YouTube chat box, on Twitter, or on the Meetup page, if you do have a question, ask it there now. But for right now, I have a question for you, Jonas. Why did you decide to create the EMF Forms project?
Yeah, so thanks for the question. Actually, the motivation was that the same as for many projects that we kicked off at Eclipse. So we had this problem ourselves. So we had customer projects where a lot of forms had to be created manually, and it was actually our task to do so. So we didn't want to spend that much effort on just repeating the same exercise all over again. So we came up with the idea to do this more efficiently, suggested that to the customer, and they obviously liked the idea because at the end, it was much cheaper for them with this framework. Yeah.
Awesome. Okay, so I guess there's no other questions. So if anybody wants to reach out, you can hashtag us at Virtual Eclipse or comment on this video after we're done the live stream, and we will get your questions to Jonas. I would like to thank everybody for coming out, and I would like to thank our speaker, Jonas. That was a great presentation. And we will see everyone next week at our next virtual meetup. It will be taking place on Wednesday, same time, with Emily Zhang and Heiko Rupp, and they will be showcasing microprofile version 1.2. So I hope everyone has a great day. Thanks for coming out, and we will see you next week.